Welcome to Mathenatic. We are busy revising content for paper 1, and in this video we'll prove where the formula for the arithmetic series comes from. So in the previous video we explained what an arithmetic sequence is, and that's a sequence where there is a constant difference between terms. So Sn means the sum of terms, and we are going to add term 1 with term 2, term 3, all the way to the last term that we observe. And in the previous video, I explained that term 1 is represented by A, term 2 is represented by A plus D, and term 3 is represented by A plus 2D. And that's all that we do in this part of the proof. We are simply writing the terms in terms of A and D. In our second step in this proof, we write the sum of terms out again, but this time we do it in reverse. So instead of saying term 1 plus term 2 plus term 3, we do it now backwards. So term 1 would be at the end, term 2 would be the second last term, and term 3 would be our third last term. And can you see that our last term would now be our first term? And notice that A plus n minus 2d represents the second last term. So when I wrote out Sn, I was very careful to put the pluses over each other so that I'll have the first term over the last term and the second term over the second last term, and then that pattern swaps around at the end. So we'll have the last term over the first term. And can you see, if I add up the blocks, so I'll have Sn plus Sn, that is equals to 2Sn. Then I'll have A plus A, that is 2A, plus n minus 1d. So I simply add these terms together. And I continue doing that for every block that I have created. Now notice what happens in the second term. We have A plus D, and we are adding A plus n minus 1d. So A plus A becomes 2A. And then in the second term, we are adding n minus 2d to d. So n minus 2d plus d simplifies to nd minus 2d plus d. And that becomes nd minus d. And can you see that d is the common factor? So therefore, if I take out d, I have n minus 1d. And that creates the n minus 1d that you see in our second term. Now that pattern of creating n minus 1d would continue for every grouping that we have created. And can you see, when we add the two lines together, that we have 2Sn, and every single sum of terms, or those blocks, creates 2a plus n minus 1d. So that means if I have in my term or in my series an n amount of terms, that I'll have an n amount of 2a plus n minus 1d's. So let's say, for example, we only had 3 terms in our sequence. Can you see that we have 1, 2, 3 of those terms? So it's 3 times 2a plus n minus 1d. But we don't only have 3 terms, we actually have an n amount of terms, and that's where that n comes from. Now, in order to find Sn alone, we need to divide both sides of the equation by 2. So therefore we have Sn is equals to n divided by 2 multiplied with 2a plus n minus 1d. Thank you for watching. Support us by liking and subscribing to Mathenatic. Check out our Digistore for math study notes, with free downloads for statistics and financial math. Follow the link in the video description.